I feel it blessed, rose for Christ. You gotta come, remember in class, we don't chew gum. Get off your phone and pay attention, not to mention you're your detention.
Hey, it's Mr. Ng going over my textbook Reveal Module 3 formula sheet on polynomial functions. Module 3, Lesson 1, Example 0. I asked you guys to write down this factoring flowchart. The factoring flowchart, before you factor, you're always thinking about the GCF, the greatest common factor. The second thing you want to do is count the number of terms. You might have 2 terms, 3 terms. I ran out of space and I wrote 4 terms. The first one, underneath 2 terms, is that you might have something called the difference of squares. That's abbreviation for squares. And what you have here is, looks something like this. And this one is kind of missing. But you'll have, the formula is something squared minus something squared. And the formula is a minus b, a plus b. Now, if you're given this, just add a 0x to it. So it might say something like x squared plus 0x. That should be a minus sign. Minus 4 squared, something like that. If you have 2 terms, it also might be called something called a, give it a second, difference of cubes. Sum and difference of cubes. A minus b to the 3rd power. Once you find your a value and your b value, you substitute it in here, inside parentheses. A minus b, a squared plus ab plus b squared. A way to remember this is SOAP. The same math operation for S. O is opposite of this, which is plus. And this one is always positive. Your sum of cubes, sum is plus. So a plus b to the 3rd power is equal to a plus b, so same, a squared opposite, the signs will change, AB plus, this is always positive, B squared. Again, if you had, you can write this out 3 times, A plus B, A plus B, A plus B, and you'll get this. But that's kind of difficult going from here to that direction. So that was 2 terms. Now, if you go to 3 terms, this is where we've been using something called the Xbox method of factor. Now, not only does this work for quadratics, which means the power of 2, this also works for something like the power of 4. You need to have 3 terms, 1, 2, 3. And half of 2 is 1. So the degree here, as long as it's half, this will work, the trinomial. If this was like a 3 and this was a 2, that might lead you to think about trying to find the greatest common factor first. In this method of factoring, you're taking the coefficients, the numbers in front. So a times c, you're going to write the number here. The b value you're going to write at the bottom. You're going to think of 2 numbers that will multiply, and their answer or their product is this number. And the same 2 numbers that you pick, you add, or their sum is the b value. Now, once you find these 2 values, you can go ahead and put them in your parentheses. Whatever is your answer here and here, you're just putting right there. Now you'll notice I put the trick below. When your a value is 1, you only have to do this x, and you can put it in there. You factored it. Now when your a value is bigger than 1, like 2, 3, or 5, you're going to have to put these pink terms into the box. You are splitting this term, so if it's x to the first, you're just having an x. If this was x squared, then you would have x squared. This whole term in yellow goes in the top left. The c value goes into the bottom right always, and then you're trying to factor these out. And then whatever you have on the outsides, those are what goes in your parentheses. That's called the Xbox method of factoring. Alright, if you count it and it has 4 terms, you have 2 situations here. This one is called a perfect square trinomial, because when you write it out, it actually looks like a perfect square. And really what it is just when you factor this, if it is 4 terms, if you can squish it together, it's just a plus b, or a plus b to the second power. The second one is called factoring by grouping. You have 4 terms, and you just put them in a box in a form of a z. The other one I've taught you in class is you can also use something called a 2GCF method, 2 greatest common factor method. Alright, let's go now to 3.11. And this method is called chunking. Chunking says you take the first 2 terms, so like ax squared plus bx, and you don't put the c value there. And what you're going to do is you're going to chunk the first 2 terms. So take this whole term, let's put it in yellow here, and what you're going to do is solve this. You want the answer here in that parentheses. I use the letter Z. You can use any letter. Common letters are U's and W's, and you're going to do this substitution. You're going to factor for X, and then you're going to substitute it back in when you're done. The chunking method works when you want to factor this trinomial, and these numbers are very large. So you could use the Xbox method of factoring, but it just works if you do it that way. Alright. In 3.13, you were factoring quartic. That one says trinomials. Quartic is to the 4th power. You'll notice on my formula sheet here I don't have numbers, so you could use Xbox. And the difficult part for students is like you're going to have x to the 4th, x to the 2nd, x to the 2nd there. So after you factor here on the outside, those will go here. It'll be x squared, because when you multiply x squared times x squared, so I don't have that down there, x, you're putting those on the outside. When you have x squared times x squared, that gives you x to the 4th. Another way of factoring higher degree polynomials to the power of 4 is using something called quadratic-like, or substitution. You basically want it to be looking like this kind of form. Plus some kind of constant. And so that way you're making it smaller to work with. In 3.14, when we're using the sum and difference of cubes, steps to factoring the sum and difference of cubes. Number 1, take the cube root so you get a and your b value. Can you do this? Whether it's plus or minus. Number 2, write down that formula. I wrote SOAP here, because that's a reminder to do one of these. and then your substitution, and then simplify. In 3.20, we learned that if you have a graph and if it crosses the x-axis, these have a lot of names to them. These are called real zeros, roots, solutions, or x-intercepts. Now the reason why they call these zeros is that, for example, let's say 4, 0. Well, the y portion is 0, and the number is your x value. So x equals that number. So we said 4, so x equals 4 would be my 0. In 3.21 and 3.22, we asked you, well, if you were given a factor, let's just say x plus 4, now you could write it without parentheses or with parentheses, and to go from this to this, all you're going to do is, well, if this is a x plus 4, you would just subtract it and you would get x equals negative 4. So when it says x equals the number, that is called a 0. That's what we had above. Right here. And they go vice versa. Just put a red box. So if they gave you a 0, you can move this over. So this number has x, say x minus 4 equals 0. Now that becomes a factor. In 3.23, we were solving using graphing. Same idea, when it crosses the x-axis, that's called a real 0. And when it doesn't touch the x-axis and it's possible it has like a bounce, those are called complex zeros. Now, complex zeros are graphed on a different Cartesian plane. Not on this one, where this is x's and y's. Notice that doesn't have an I in there. 3.24, we were solving by factoring. So when it says solve, you want to set it equal to 0. So if you have two sides of the equation, say there's stuff over here and here, you basically just want to move everything to one side. And then you want to try to use the methods you've done in quadratics. Square root method, factoring, quadratic formula. In 3.30, we were getting rough sketches, and we got the rough sketches by using something called multiplicity. So the first thing is it factored? And if it's not factored, go ahead and factor it. Then get a basic graph. So something like x to the first, and then x to the second, looks like this pink. Now the multiplicity is the degree. So if I have something that looks like this, that means multiplicity is the number up here. After that, you're going to do something called the zero product rule, which basically means to solve it. Set this parentheses equal to 0. When you solve it, you'll get a 0, which looks like this over here we just talked about. And if this number up here is an even, the multiplicity is even, you're going to kiss. So here's an example of kissing. It kisses off the x-axis. And in odd, so like if there's nothing there, that's a 1, 3, you would do something like this. It shoots through that point, goes through it. We haven't really talked about it much, but you can also do transformations and then graph it. In 3.4, we were trying to find the remainder. You can find the remainder in a couple of ways. You can find the remainder using long division of polynomials, synthetic. And this is the one where you're using your 0 on the outside. This one uses a factor. And this one you use a 0. So any of these methods would help you find the remainder. In function notation, f of x, this x value is the 0. And that's what you're substituting into the function when you're using the remainder theorem. We use the remainder theorem with the factor theorem. The factor theorem says if the remainder is 0, then it is a factor. But if it's not equal to 0, so it's equal to 35, then it's not a factor. Basically, okay, going back to this picture, that's the remainder, your y value, and then if it's like 16 or something like that for your y value, then it's not a factor. 3.5, we were talking about the fundamental theorem of algebra, where the degree of the polynomial is equal to the real zeros plus the imaginary zeros. The imaginary zeros come in pairs, or it's an even number, 0, 2, 4, 6. This can be odd or even. In 3.52, we said that the possible positive real zeros is just counting the sign changes. In front of a polynomial, is it plus or minus, and to the next one, what is it? If it is like a negative to a positive, then yes, that's a sign change, and we count the yeses. That tells you the number of real zeros. To get the possible negative real zeros, you're first going to put in negative x and simplify. Then you're going to count the sign changes. If it's a yes, count it, and then you can put it into our chart. Our chart, we said, is when the real zeros are more than 1, you want to count down by 2 towards 0. So for example, if we counted the number of negative real zeros and it was a 4, then I would have to write this 3 times. 4, 2, and 0. Remember, this is the imaginary zeros, the equation up here, so they have to come in pairs, and it's even. Basically, what you're trying to do is figure out all the combination of numbers there. In 3.53, you're going to get a hint. I might give you a table of values or a graph, and it might tell you like f of some number equals 0. That means the remainder is 0, so that means it's a 0. Your clue, look at this picture here. This is a review, right? If this is an x-intercept, then I want that number. That number is x is equal to a number, say 4, and that's called a 0. If I move this 4 to the left side of the equation by subtracting 4, say it says x minus 4, then this is my factor. And then in 3.54, we got a chart, so we're given a graph, and we took the characteristics of that, writing down the x-intercepts. Those are numbers, like x equals 4, and then is a shoot through or kiss, so it's either going to be a 1 for a shoot through, or it's an odd multiplicity, and a kiss would be 2's. We want to find the leading coefficient by looking at the basic graph, figure out its degree by doing the turning points, right, from when it changes from increasing and decreasing, or decreasing and increasing, is equal to degree minus 1. And then you want to substitute it based off of how many x-intercepts you have. So if you have 3 x-intercepts, you would use 3 sets of parentheses. The multiplicity, if it's 1 or 2, would go up here. A value is either going to be positive or negative, and that's your leading coefficient. I hope that was helpful. See you. Bye.
Mathematics includes the study of quantity, structure, space, and change. Math can be so complex it could be considered strange. So strange equations could be rearranged. Don't even get me started on fractions. To multiply them, it's going to take a lot of action. But math can be simple. All it takes is practice. Your brain is like a muscle. Make sure it's active.